Hey everybody, welcome back to this video. In this particular video, we will be discussing some of the intermediate level SQL problems. Now, the questions I will be discussing specifically have been asked in some way or the other in some of the MAANG companies. Now, it might not be the exact question that have been asked, but the pattern is something that we pretty much see whenever we appear for any of the product-based companies like MAANG, or for that matter, some of the other companies like Bloomberg, Uber, EPAM, and so on and so forth. Not just that, if you are looking to prepare for some of the advanced level data roles like a data engineer, a data analyst, a data scientist, or for that matter, the AI engineering roles, which is very popular nowadays, you will most likely come across scenarios where SQL will be tested. And my intention in this video is to prepare you for the same. The questions that I will be discussing are not just theoretical textbook questions, but they will actually test your concepts of joins, aggregations, filtering, as well as how you can apply the concepts of SQL into real life scenarios in the questions that are given. I will also discuss some of the common pitfalls that you might come across when you are actually framing the solution. The entire solution that I will be framing will be under the constraints that interviewers usually give and interviewees usually face. So without much ado, let's get started in the solution. Now let's look at the first problem. It says we are given a calls table that has the columns from ID, to ID, and duration. Let's look at the data. Okay, so we have a from ID, we have a to ID where mostly it represents people by means of IDs, and we have a duration, most likely in either minutes or seconds. Now the duration unit is not mentioned, which is actually fine. The table does not contain a primary key, so duplicate records might be there, which is again okay. Now let's look at the task. It says for each unique pair of users, we have to find the total number of calls exchanged and the sum of the duration of calls. And also the output format has to be returned in a way that person 1 is less than person 2, as in the representation. So let's see how the logic needs to be framed first before we actually go into the SQL. So this is the data. Let us first identify the pairs. We have 1 and 2 over here, and the duration is 59. We also have a 2 and 1, and this duration is 11. Do we have any more 1 and 2s in this data? We don't. So for this particular pair, if I am to represent it as per the requirements in the question, my from ID needs to be lesser than the to ID. So it's going to be 1, 2. So the from ID is 1, the to ID is 2. The total number of calls that have been exchanged between these pairs is 2, and the total duration is going to be 59 added to 11, which is 70. Let's identify the other pairs as well. We have a 1 and 3, and the duration is 20. Do we have any more 1 and 3s? We don't. So this is going to be 1, 3. This is just one call that has been made, and the total duration is 20. Now we have a lot of 3s and 4s, so I'm just going to copy it instead of typing it again. And we have a 4 and a 3 as well, which belongs to the same set because they're the same set of people. Now all of this needs to be combined into one result set. So over here we have 3 is the from ID, 4 is the to ID. Total number of calls that have been exchanged between this pair is 4, and the sum of this is 999. This is a separate pair by itself. Okay, so this is how the logic is going to look like. Let's try to figure this out in a SQL query. I'm just going to select the data first just to see how it looks like. Okay, so I'm going to solve this by means of common table expressions. If you are aware of common table expressions, you are in a good shape, but in case you're not aware, just read it up. It is very simple and it acts like a subquery. With P2P, I'm going to name this common table CTS P2P as select from ID as person 1 to ID as person 2 and duration from calls this satisfies my first case where the from ID is lesser than the to ID. Now I also need to take care of the other pair as well, which is the to ID is greater than the from ID, which is the second case. So I'm going to do that. I'm going to do a union all. The reason why I'm going to do union all over here is this table has duplicates which has already been called out in the question. So I'm going to copy this entire subquery and to paste it over here. But in this case, I'll just change this. I'll make this to ID. I'm going to make this from ID because I'm reversing the pairs. And I'm going to also reverse this condition. Now let's see how this data looks like before I proceed further. So I have 1 and 2 coming as 59, same as 1 and 2 coming as 11. So if I just do a count for the total number of calls between 1 and 2 and just sum up the durations, I think I should be in a good shape to have the solution. Same goes for 1 and 3, which does not have a pair. You can see 3 and 4s are also in the same order. So I can just sum it up and I should be good. So select person 1, person 2. Let me check the data format for the output, which is very critical. So it says call count is the count column name and total duration is the duration column name. Count 1 as call count, sum duration as total duration from P to P, group by, I'm going to group it by the first and the second. Now I can use 1 and 2 over here, but if you're using a MySQL and an Oracle, you might have to explicitly mention the column names, or for some of the other databases, ensure what the syntax is that you're using. I'm using Postgres, so it allows me to actually use the column numbers rather than referencing it with the name. Let me run this. Perfect. We have a 1 and 2 with the duration of 70 and 2 calls being made. We have 3 and 4 calls being made with the duration of 999. And we have a 1 and 3 with 1 call being made and the duration of 20 minutes. So the solution is correct and it does not require any ordering because the question clearly says that the result can actually be returned in any order. So this solves the first question. Let's go to the second one. Now let's look at the second question. We are given an employees table that has 3 columns: the employee ID, the employee name, and the manager ID. Let's take a look at the data. This is the employees table. Looks to be a pretty straightforward employee table. Now what does the question say? It says the company head is the employee whose employee ID is 1. So basically the employee name is boss, who is the company head. It asks us to write a SQL query and return the employee ID of all employees who report to the company head. However, there is a catch. It is directly or indirectly through 1 or more levels, and it has to be no more than 3 levels of management. Okay, now let's see how this query can actually be solved. But before that, let us frame the logic. So this looks to be the employee table data. At the first top hierarchy, we have 1, who is the boss. Now let's look at how many people report to the boss directly. we have Bob, who's reporting to the boss, and we have Robert, who's reporting to the boss. So I'll just add the employee IDs at the second level, 2 and 77. Now let's look at how many people report to Bob, who's employee ID 2. We have 1 is Daniel, and that's it. So only one person reports to Bob. So I'll add that level as 4. Okay. Now let's see how many people report to 4 employee ID, which is Daniel. There's just one, Louise. And that's my third level, which is employee ID 7. So essentially my output should be 1, 2, 77, 4, and 7. Let's see if that corresponds with my output that's there on the question. 2, 77, 4, and 7. We are ignoring 1 because we don't want to consider the top level. Now let's solve this problem. Let me first display the data. It's always a good idea to have the data in front of you when you're actually writing your SQL code. Now, there are two approaches of solving this problem. One is the rudimentary approach. Let's try that. Select Now what is this going to give me? It is going to be give me everyone who is reporting to employee ID 1, but not the boss himself or herself. So it's going to be 2 and 77. I'm going to do a union, select employee ID from employees where. Now I need all those employees who report to 2 and 77. So I'm going to just add this condition in the subquery. This is going to be my second level. Again, a union condition. Third level is the same. I need all the employees who are the output of the second level. Let me actually run this to see if this works. Works perfectly. But there are two fundamental problems with the SQL query. Number one, it's from a performance perspective where the number of nested queries that keep on increasing that actually result in a very degraded performance. Imagine if this was 10 levels down, right? And imagine the last level, the subquery structure, how it would have been. It would have been one nested subquery inside another. That would have been a really non-performant query structure. And the second problem with this particular approach is the code maintenance perspective. If let's say you are to do this for 100 levels, now doing this 100 times and repeating each thing for 100 times, and the length of the subquery and the amount of code that you have to write, it's like too much to manage. So essentially this approach is something that is not going to be a production effective approach, I would say. Now let's try something else. This problem can also be solved by means of something that's known as a recursive common table expression or recursive CTE. There are recursive subqueries as well, but we'll be doing this with the common table expression approach. Let's see how that works out. A recursive common table expression has three parts to this. One is the anchor query or the anchor member. Second one is the recursive member, and the third is the termination condition. Now these are the three elements that are responsible for a recursive query to function. Now all of these elements have to be present in a recursive CTE, and they have to be in the same sequence or order. You cannot change the order. Let's try to write a query with recursive CTE as. Now I have to put the recursive keyword for Postgres. It might not be required if you're working with some other database. Select employee ID from employees where manager ID, and this gives me the first level. Now I also have to add something that's known as a level operator, which is actually going to tell me what level the particular query is in. I'm going to add one as level. So this gives me the anchor member union. Now I have to put the recursive member. Select employee ID from, as you might have guessed, since it's a recursive query, it's going to refer the CTE as well. Inner join employees on CT.employee ID equals to E.manager ID. I also need to increment the level for the second reference, which is going to be level +1. So this gives me the recursive member. Now the final condition that I need to add is the termination condition. So my termination condition is level, which are 3 in nature. So it will be level less than equals to 3. Now let's see if this query works. I'm just going to put star from CT. It says an ambiguous reference. I probably have to give the reference of the query I'm referring to for the employee ID column. And this is going to be the employee table. Perfect. So we have the employee ID and the levels associated. Now, if I look at the final output, that doesn't require me to give me the level. So I can just ignore the level column over here and just put the employee ID over here. Great. 2, 7, 4 and 77. 2, 7, 4 and 77. Perfect. So this is how we are going to tackle questions like this for a query that deals with hierarchy, instead of writing multiple subqueries and having a degraded performance in your overall query. Recursive subquery or recursive CTEs are very powerful tools in SQL. It can actually help you use certain functionalities like we have in programming languages like Python for loops, while loops, as in case of iterations. The same thing can actually be implemented by means of recursive CTEs or recursive subqueries. Now, does that mean we can actually print the output for a recursive pattern like a Fibonacci series? Turns out we actually can. And this is what I would like you, the viewers of this video, to actually put it down in the comment section. What can be a recursive subquery or a recursive CTE and the overall query, which can actually print the output for a Fibonacci series. We will discuss that in the next video. This brings me to the end of this particular video. Thank you for staying a part of it. Please like, comment, and subscribe if this finds importance and is helpful for you. Thank you.